to the Coded Bro, and today's topic is graph using adjacency list. So first of all, what is graph? A graph is a non-linear data structure made up of nodes or vertices and edges, right? Now what is vertices and what is edge? First of all, I will just draw it, right? So just draw it. So this data structure is basically known as graph, right? Where this represents vertices, here 0, 1, 2 and 3. These all are vertices, or in short, for individual we say vertex, and for combined we say vertices, right? And the relation between 0 and 1, which is represented by this line, right? This line is known as edges, right? So edges is always between two nodes, okay? For example, in this example, 1 and 2 is represented by this edge vertices, right? That means 1 and 2 both are connected, right? So we have covered vertex, we have covered edges. Now graphs are of two types, right? Graphs are of two types, directed and undirected. What does this mean? Directed means, like, if let's consider an example. Let's say from 0 to 1, right? If I am going from 0 to 1, this edge represents that vertex 0 and 1 both are connected, but there is no mention of direction. That means I can go from 0 to 1 also, and from 1 to 0 also, right? There is no limitation in direction. I can go anywhere. So if I want to say that I can only go from 0 to 1, I will represent it like this. This means I can only go from 0 to 1, but I cannot go from 1 to 0, right? This is directed graph. Let's consider this example only. In this example, from 0 to 1, right? I can go from 0 to 1, from 1 to 2 I can go, and from 2 to 3 I can go, right? 0 to 2 I can go, but I cannot go from 2 to 0, right? From 0 to 2 I can go, but from 2 to 0 I can't go, right? So this is directed graph, this is directed graph, this is undirected graph, right? Now there are also two more types in directed and undirected graph, that is known as weighted and unweighted graph. What does this mean? Consider our first example only, from 0 to 1 and from 1 to 2, right? And from 2 to 3. In this example, the edge here doesn't represent any weight. Weight means, like, there is some value, right? From going from 0 to 1, how much distance it is taking, in terms of computer science, how much weight it is taking, right? So in unweighted graph there is no representation of weight, whereas in weighted graph there is representation of weight, right? For example, I am giving from 0 to 1 1, from 1 to 2 2, and from 2 to 3 let's say I have given 5, right? So as you can see, to traverse from 0 to 1, there is a edge weight minimum distance of 1 I have to travel, right? From 1 to 2 there is a distance of 2, and from 2 to 3 there is a distance of 5. So this is a basic distance of weighted and unweighted graph, right? Now coming to the part of in degrees. What does in degrees, what does in degree means, right? In degree is generally the term used to represent the number of edges coming towards a particular vertices, and it is usually represented in directed graph only, right? So if you consider this example, let's say we are considering vertex 1, the in degree would be 1 here. Why? Because from 0 to 1 only one edge is coming and one edge is going out, right? So if I say in degree of 1 is 1, right? only one number, only one edge is coming, that is this edge is only coming, this edge is going out, right? This edge is going out. So we know the in degree. Let's consider one more example of in degree. For example, this is 1, and from 1, let's say this example, right? And in this example, the in degree of 1 would be 3. Why? Because 3 edges are coming in towards 1, right? Therefore in degree of 1 would be 3, right? So let's just so this is in degree. And now what is out degree? So you can consider opposite of in degree, right? If edges are coming inside, then the edges which are going out would be the out degrees. For example, let's consider again this example of 1. So in this 1, the edge 1 is going out. From 1 to 2, this edge is going out. So therefore out degree of 1 would be 1, right? In this in this example, out degree of 1 is 0, because there is no edge which is going outside, right? So therefore out degree of this particular edge 1 in this example is 0, right? Now coming to the main part, like how we are going to represent this, edge in terms of computer science, like in terms of coding, right? How this how we are going to implement this node. So today's topic is only for adjacency list, but to represent graph in code, there are broadly like two ways. There are to represent graph, there are generally two ways. First of all, adjacency matrix, and second way is adjacency lists, right? There are more ways to represent, but these two are more generally and most widely used ways to represent graph in graph in terms of data structure, right? Used to represent graph in terms of data structure. Our today's topic would be adjacency list. In the next topic I will explain about how we are going to implement using adjacency matrix. Yeah, so let's just start with adjacency matrix. So let's just consider our first example only, from 0 to 1, from 1 to 2, from 2 to 3, and from 3 to 0, and from 2 to 0. So this would be our graph, right? So as we can see in our graph data structure, what are the main things we want, right? So let's say in C++ we are making a graph class, or any programming language. Let's just say we have a graph. So what we are going to represent here in our graph, we are going to represent how many vertices are there, right? Okay, so vertices would be our first parameter, like a variable, or we can say property, right? In our graph, vertices would be one properties. How many number of edges, how many number of edges, right? In this graph, 1 2 3 4 5, there are 5 edges. So how many edges, right? N vertices and n edges. How many edges are there, how many vertices are there? So after this you should know our graph is directed or undirected. Yeah, so directed would be our one property, right? After that we should also know the degree of 1, right? What is the degree of 1, right? Like how many in degrees are there, how many out degrees are there. So for this now we will for now we will just consider one variable only, one property only, that is degree, which represent both out degree and in degree, right? So in this so how I am going to represent, right? So first of all we will initialize an array, right? Initialize an array to the total number of vertices, right? Which is total number of vertices, and each vertices will represent its in degree and out degree. For example, and each vertices will represent its degree. That is from, let's say for this example, 0, 1, 2 and 3. So in degree of 0, since it is undirected graph, right? Since it is undirected graph, I will consider both in degree and out degree, and there is two ways, right? You can go from here to here also, right? So let's say in degree of 0, what would be the in degree of 0? 1, 2, 3. So same for out degree also, because since it is undirected graph, in degree and out degree is same, right? So for 0, 3, for 1 it's 2, for 2 it's 3, and for 3 it's 2, right? This is our representation of degree. So once we have done with our degrees, the next and the most important variable would be our edges. Up till now we know how many edges are there, but we don't know what are the main connection of edges, right? From, like, let's say we have one edge from 0 to 1, how we are going to represent this edge, right? And for this edge we should have one more data structure to represent the edge, which is known as edge node, or you can name anything. You can just represent edge also. Edge node would be like something like common name people use every time, right? So in this edge node, our first property would be adjacent, right? Adjacent means if this is 0, right? Like if this is the vertex number 0, the 0 has 3 adjacent, right? From 0 to 1, 0 to 2, 2 to 3, right? So what would be the adjacent? So we should know adjacent also, right? So this is our one property. After that, if there is weight, right? If we are giving weight, so we should know weight also, weight of edge. So if there is no weight, we could constantly give any number, right? Like if we say every edge weight is 0, so this means that it is unweighted already, right? Because even if there is a weight, like we cannot do, because we cannot do anything because all weights are same, right? So weight would be our next property, and we should also know the next edge, right? Next edge, like next adjacent edge, let's say from 0 to 1 is 1, from 0 to 1 we have, from 0 to 1 we have one adjacent, and from 0 to 3 we have one more adjacent, right? So from 0 to 1 is one edge, and adjacent would be from 0 to 3, right? So this is adjacent edge of this edge, right? This is adjacent edge of this edge, so we should know that also, right? So this is our edge node data structure. So coming to our graph data structure, we should also have one array of edge node, right? We should have the array of edge node, right? So this is what our data structure broadly looks like, right? For we just need this much property only to implement our graph data structure, right? So this is very basic. Now I am going to implement this in C++. See you guys in next section towards coding. So welcome guys to the coding section, and as we have discussed in our previous section, we are going to implement graph data structure in C++. So let's just start. So first of all, as discussed in previous section, first of all we need a graph data structure, right? And in our graph data structure, the properties would be, right, properties would be vertex, like a number of vertex, right, and their number of edges, right, and is graph directed or undirected, right? Is directed or undirected, right? Sorry, direct or spelling is wrong. Directed or undirected, and like degree, what is the degree of our graph, and what are the connection of edges, right? Like which from which vertices to which vertices which edge is connected, right? So we want that edge node connection, right? So first of all, we will start with implementing our edge node. So because edge node is most important thing, first of all we should implement that. So as discussed in previous section, our edge node, so So our age node class would have the properties, our age node would have the properties, first of all, int adjacent. So I should know what is the adjacent. As discussed in previous section, if 0 to 1 was our current age node, then it adjacent would be from 0 to 3 or from 0 to 2, right? So we should know the adjacent, and then int weight, right? If there is a weight, we should know the weight of graph, and then similarly we should know age node, next age node, right, which is our next age node, right? So mostly I initialize it to null only, because like if there is no age node, we should not go to any garbage value, right? Most of the time it doesn't go to any garbage value, but initializing it to null would be a safer option, right? So right now we have created the age node. Now we will create our graph class. Now we will create our graph class, and as we know, before graph class, let's just make it public. If you don't make it public, it would be private, and we would not able to access our variable, right? So now in this graph data structure, let's just first make it public. Yeah. So we know we have to we have to know number of vertices, right? Int vertices, right? And it would be n vertices, right? How many number of vertices it have? Number of vertices, right? And after that int n edges, right? Number of edges, right? And after that int, and after that boolean directed or not, right? Is like boolean is directed or not, right? And after that we should know the degrees, right? And for these degrees we should implement vector int degree, right? And after this we should know what are our edges, right? Vector edge node and edges, right? What are our edges, like what are our adjacent edges? So once we have implemented this, one more thing, before, like we should make a default values in our vector edges, right? Like you will get to know when we are inserting any edge in our graph, we will know why this basic initialization is needed. So first of all, we will make a constructor, right? And in constructor we should know how many number of vertices in our graph are there. So once we know how many vertices in our graph are there, we will just implement a while loop, or you can implement a for loop also, like there is no necessity. So like while I is less than equals to v, right? Edges, like first of all we will consider new edge node. So edge node star edge is equal to new edge node, right? And then, and in our edges array we should push back this edge, right? I guess we have some error, right? Oh sorry, I have used same variable name for this same, right? So yeah, and this push back node, this is pushback, right? Yeah, so we are good. And in our in degrees vector we should initialize all degrees to be 0, right? So degrees dot push back 0, right? So this is basic initialization of our vector arrays of edges and degrees. So this is our basic data structure of our graph, right? This is how our graph gonna look like. So let's just start implementing like how we are going to insert in our graph, right? Insertion is most important thing, right? So before insertion, so let's start with insertion, right? Void insertion, and instead of insertion we will just make it insert only, void insertion. And inside this we are going to send graph as our first parameter, and after that int x, which would be the from edge, and y would be the to edge, right? That means from like this vertex to this vertex, right? So from source to destination, right? Int the weight of our edge, and and boolean is directed or not, right? Is directed or not. So yeah, we have sorted our error, and let's just start with implementing insertion. So for insertion, let's say we have sending source and destination, right? In terms of our int. So we should first create an temporary edge node, which we are going to insert, right? Edge node is equal to edge is equal to new edge node, right? And new edge node. And after this, once we have created our edge, we should assign the weight of our edge, right? We should assign weight, right? Let's just start filling the properties. We know edge weight is equal to weight, we are getting from here. And after that, edge, we should know adjacent, right? Adjacent means destination, from source to destination, right? So here y is our destination, right? And like from where, which source. So now as you can see, from here what we would do, we would pick the edge from our this array, from edges array from our graph, and from this graph we are going to link this edge, with this edges graph, right? I will explain in this like previous section. So what actually is going on, right? So let's just consider one example, that is from 1 to 2 and from 2 to 3, right? Let's just consider. So according to our graph data structure, we have initialized one edges array, right, with the total number of vertices, right, total number of vertices. And now we know that let's just consider his 0 1 2 1 and 2, right? So now we know, like, we have to store these edges in our this list, right, this array. So let's say our source is 0 and our destination is 1, and edge weight would be 1. Let's just consider for example 1, right? So what I am doing according to my code here, first of all, I am taking a temporary edge node, right? I am assigning adjacent here as my like destination as 1, right, and my weight as 1, and I am assigning this edge node to this, like I am pointing out this edge node to this, right? And let's say now our source is 1 and our adjacent is 2, right? So in this example also, what I am doing here, I am considering one more node which has adjacent as our 2, weight is our 1, and it would be linked to this one, right? This is, if this is 0, this is 1, and this is 2, right? So I am assigning this. So this kind of list we are making, and we are assigning to this list, right, array of lists. So coming to the code implementation part, now we are in the part of insertion, right? So once we have assigned our adjacent, now what I am going to do is this current edge next, right, is equals to our graph's source, right? Our graph's source, like our graph's current source edge, that is from G to edges, and which would be our x, right? And one more thing we will do, we will just make this edge, right? We will make this current edge as our, we will make this current edge as our edge, right? So we are going to store in the reverse order, right? Reverse order of our insertion. Okay, and now what I am going to do here, let me just correct this mistake. Yeah, right, we are good to go. Here not edges, yeah, very good. So after edges we would now increment the degree, right? We should know degree also, and after degree we should also know total number of edges, right? Total number of total number of edges. So if there is one edge, now most important thing, if the graph is directed, right? If graph is directed, we should know that also, because if graph is directed then only we are going to insert one edge, but if it is not directed we have to insert in two ways, right? From 0 to 1 and from 1 to 0, and which is very simple, right? First of all, what we will do, we will just call this insert again, right? And in this insert, what we are going to do, we are going to send graph, and we will just swap the positions of source and destination, right? In place of source we will keep destination, and in place of destination we would keep source, right? And again we will send weight also. If there is weight, we will send weight also, right? And this time, instead of directed, like if it is directed, right, we will send it true, right? We will send it true. If it is if it is not directed, once if it is not directed, so in next iteration this directed will become true, but here it would be like false, so we will come out of this insertion function, right? So we have done with our insertion part. Let's just start implementing our int main. Like up till now what we have implemented, is it working or not, right? So let us start with graph star g is equal to new graph, right? And we will just call our insert function. And first of all, before insertion in this graph, how many vertices we need, right? Currently we need 4 vertices. We are going to send this as 4 vertices, and let's just start with insertion, right? So considering our this example, I am just here somewhere the photo of our graph will be pasted, right? So our graph would look like this, right? So how we are going to insert? First of all, in insert I am going to send graph, then source, then destination, then weight, and is it directed? No, it is not directed, right? False spelling is wrong, sorry, my mistake. Right, and let's just paste this 4 more times according to our example, right? Right, and from our next source is 1, and from 1 to 2 we are going, edge weight is 2, and from our next from 2 to 3, from 2 to 3 the edge weight is 5, right? And from 3 to 0 our edge weight is 4, and from 2 to 0, right, our edge weight is 3, right? So this is how we are going to insert. Let's just run. So we don't know if it is properly assigned or not, right? Let's just create a print function for this. Let's just say void print edge print graph, right? Print graph, and here we are going to send graph star g, sorry, my mistake, yeah. And let's just take one edge node pointer, right? We required here edge node pointer. Once you have assigned this, edge node pointer, we are going to make an for loop, right? Int j is equal to 0, j less than equals to j less than graph number of vertices, right? And now you will know why I am like we are looping over only vertices, not edges, since in our this graph data structure the edge node we have here next, right? So once we have currently in our like for one vertices, we are going to traverse all the edges, right? We are going to travel all the edges, adjacent edges, until it is not null. So that's why we are just looping over our vertices only, we are not looping over edges, right? So we have done with the edges, and let's just print j here plus 1, and let's just start in our inside for loop. So inside for loop, first of all what I am going to do, I am going to point our edge from our graph, right? Edges of j, right? Once edges of j, once we have got our j, first of all I need to print source, right? What is my source, which is our j, right? Which is our j. And after that I will apply a while loop while p is not null, right? While p is not null, I will just print the adjacent, right? I will just print the adjacent, or as we can say destination, right? As we can say destination also, and my destination would be p's adjacent, right? And yeah, p's adjacent, and cout, sorry, not cout, and we are going to just make it next, right? P is equal to p is next, when we are going to travel next adjacent, right? Once this done, let's just make here end line just to properly format this. Yeah, so we have done with our print, function. Let's just print our graph if this is working or not, right? So I guess there is some error in our code. Let's just figure out what are the errors, right? Yeah, here I am not doing I++, right? That is most important thing. Let's just run once again. See, as you can see, our source is 0. So as we have got this error, so if you understand why we got this error, because we have not assigned total number of edges, right? Total number of vertices. So sorry for my mistake, and vertices is equal to v, right? Total. So now again we will just implement this code, and let's just see for this time is it working. Yeah, right. So as you can see, our source is 0 and our destinations are 2, 3, 1 and 0 itself, right? And from 2 to 0, from 2 to 3 and 2 to 1, right? And from 3 to 0 and 3 to 2. This last destination doesn't mean anything, right? This is just for like, in that 0 means that there is no destination, right? So from 4, okay, so we don't need +1 here, right? We are good with up to 3 only, right? So as you can see, from 0, 1, 2, 3. So I guess you guys understand how we are going to implement this graph data structure in our C++ using adjacency list. So my next video would be for adjacency matrix, and if you don't understand anything, you can comment out. And one more thing before subscribing, I would like to ask you about my explanation, the way I explain. If you find anything wrong or anything, something I could improve, please comment down below, as that would matter for me. Because if I can explain the way you want, or I can explain like any easy matter, and that you can understand, that can improve for me also, right? So that I can understand, or I can teach myself in different way, right? Like some things we should know, like to know something, there are so many ways to teach ourselves, right? There is not just one way to teach some particular topic. There are so many ways we can teach ourselves, right? So thanks for watching this, guys. Please comment down, and if you like the video, please subscribe and please like. Thank you.